Pause for a moment and think about this. The universe is almost 14 billion years old. Stars have flickered and died. Galaxies collided. Civilizations might have risen and fallen. And still, we hadn't heard a single breath of life beyond our own planet. Until now. Because thanks to the James Webb Space Telescope, we found what shouldn't exist, a world swarming with the unmistakable chemical signatures of life. It's not just maybe, it's 99.7%. That number doesn't whisper, it shouts. In the next hour, you'll hear how the data was collected, how the global scientific community reacted, and why this discovery might be the most thrilling and the most terrifying moment in human history.
In the beginning, there was darkness, and in that darkness, questions. For as long as humanity has gazed upward, we have asked the same question, whispered it to the night sky, carved it into ancient stone, encoded it into our myths and our mathematics. Are we alone? For thousands of years, we received only silence in return. The universe, it seemed, was keeping its secrets. But then, we built something extraordinary. The James Webb Space Telescope, humanity's most powerful eye. A $6.5 billion miracle of engineering, floating in the cosmic dark, nearly 1 million miles from Earth. 10,000 times more sensitive than anything that came before it. Its mission? To see what we have never seen, to find what we have never found. And on September 14th, 2024, it did.
What you are about to witness is not science fiction. This is not speculation. This is the moment everything changed. The moment we discovered we are not alone. It started as routine. Just another night of data collection, just another scan of a distant star system. Sector 7 Gamma, catalog number HD 8472, approximately 124 light-years from Earth, in the constellation Draco. An unremarkable yellow dwarf star, not unlike our own sun. 5 planets in orbit, rocky worlds, gas giants. Nothing special. Nothing that hadn't been seen 1,000 times before. But then, the third planet. The computer flagged it immediately. Atmospheric composition, unusual. Spectroscopic signature, anomalous. The algorithms that had been trained on thousands of exoplanets suddenly lit up like a Christmas tree. Something was wrong, or rather, something was right. The planet measured 1.2 times the size of Earth, surface temperature averaging 18 degrees Celsius, liquid water confirmed, orbital period 412 days, distance from its star, the perfect habitable zone, the Goldilocks region, not too hot, not too cold. They named it Eden 9b. And Eden 9b was screaming at us, not with radio waves, not with artificial signals, but with something far more fundamental, something that couldn't be faked, couldn't be mistaken. Life's chemical signature. The James Webb Space Telescope uses a technique called transit spectroscopy. When a planet passes in front of its star, starlight filters through the planet's atmosphere. Different molecules absorb different wavelengths of light, like a fingerprint, like a chemical barcode written in the language of photons. And Eden 9b's atmosphere told a story that made every scientist who saw it stop breathing. Oxygen, 21%, almost exactly the same as Earth. Methane, in quantities that defied geological explanation. Water vapor, abundant, everywhere. Carbon dioxide, but not too much. Perfectly balanced as if something was regulating it, consuming it, breathing it. Nitrogen, the foundation of proteins, the building block of DNA. And then, the anomaly, the signature that changed everything. Dimethyl sulfide. On Earth, there is only one source of dimethyl sulfide in significant quantities. Only one process that produces it. Only one explanation for its presence in a planetary atmosphere.
Biological activity, life, specifically marine phytoplankton, microscopic organisms in vast oceans, photosynthesizing, metabolizing, living. There is no known geological process that creates dimethyl sulfide, no volcanic activity, no chemical reaction in lifeless rock that can produce it. If you find it in an atmosphere, you have found life. And on Eden 9b, the concentration was off the charts. But it wasn't just the presence of these chemicals. It was the combination, the ratios, the delicate balance. Oxygen and methane should not coexist in an atmosphere. Chemically, they react. They destroy each other. Within 10 million years, they should be gone, unless something is constantly replenishing them, unless something is producing them, unless something is alive. The data was checked, rechecked, run through every verification protocol, every algorithm, every possible source of error, instrument malfunction, cosmic interference, data corruption, contamination. Nothing. The signal was clean. The readings were solid. The evidence was undeniable. Statistical models were run, Bayesian analysis, machine learning algorithms trained on every known exoplanet, every possible false positive, every alternative explanation. The probability returned was not 50%, not 70, not even 90. 99.7%. The probability that Eden 9b harbors life, 99.7%. Let that sink in for a moment. In the scientific community, 95% is considered definitive proof. 99% is beyond question. 99.7% is unprecedented. For the first time in human history, we were looking at another world and seeing the unmistakable signature of biology, of metabolism, of something living, breathing, existing 124 light years away. The universe had finally answered our question. And the answer was yes. The first person to see the data was Dr. Rebecca Chen, a spectroscopy specialist at the Space Telescope Science Institute in Baltimore. It was 3:47 in the morning. She'd been working the night shift, cycling through automated data streams, when Eden 9b's readings came through. She stared at her screen for 11 minutes, without moving, just staring. Later, she would say she thought the computer had malfunctioned, that the data had to be wrong, that what she was seeing was impossible. But the data kept coming. Every wavelength, every spectral line, all confirming the same thing.
She picked up the phone, called her supervisor, woke him up, told him to come to the lab immediately. He asked why. She couldn't answer. Her voice had stopped working. Within an hour, 12 scientists were crowded into the analysis room. The director of the Space Telescope Science Institute was on a video call from his home, still in his pajamas, watching the data stream in real time. No one spoke. They just watched the numbers, the graphs, the undeniable truth assembling itself on their screens. Someone finally broke the silence. "We need to call NASA." By dawn, the news had reached NASA headquarters in Washington. Emergency meetings were convened. The administrator, the chief scientist, representatives from the astrobiology division, exoplanet specialists from around the world were pulled from their beds and connected via secure video conference. The data was presented, analyzed, questioned, torn apart, put back together, examined from every conceivable angle. And every single analysis came to the same conclusion. This was real. The room, filled with the world's most skeptical scientists, trained to doubt everything, to question every result, to demand impossible standards of proof, went silent. Because they all knew what this meant. They all understood the weight of this moment, the magnitude of this discovery.
After 400 years of searching, after 60 years of listening to the cosmos with radio telescopes, after decades of scanning thousands of exoplanets, after countless false alarms and disappointed hopes, we had found it. The thing we'd been looking for since we first looked up at the stars and wondered. We had found life. Not a signal, not a message, but something more fundamental, more profound. The chemical signature of biology itself. The proof that life wasn't just an accident, wasn't just a fluke that happened once on a single pale blue dot. Life was out there, abundant, real, 124 light years away. The question now was, what do we do about it? NASA's protocol for this scenario had existed for decades. The post-detection guidelines, the carefully planned steps for how to handle the discovery of extraterrestrial life, who to inform, how to verify, when to make it public. But those protocols assumed we'd detect an artificial signal, a radio transmission, something from an intelligent civilization trying to communicate. This was different. This was biosignatures, chemical evidence, not a message from aliens, but the scent of life on the cosmic wind. There was debate, heated discussion. Some argued for immediate public disclosure. The discovery was too important to keep secret. Humanity deserved to know.
Others urged caution. The data needed to be verified by independent teams, published in peer-reviewed journals, confirmed beyond any shadow of doubt before making such an extraordinary claim. And then there were those who raised a different concern, a darker question. If we announce this discovery, if we tell the world that we've found life on another planet with 99.7% certainty, what happens next? What does this do to society, to religion, to our understanding of our place in the universe? And more importantly, what if the life on Eden 9b isn't just microbial? What if it's more than just phytoplankton and bacteria? What if something on that planet is looking back? The room went quiet again, because that was the question no one wanted to ask. The possibility no one wanted to consider. But the data was undeniable. The biosignatures were strong. Too strong for just simple microbes. The atmospheric composition suggested a thriving, complex biosphere. Oceans teeming with life, possibly even land-based organisms, forests, ecosystems. And if there were forests, if there were complex ecosystems, then statistically, evolutionarily, there was a non-zero chance of something more, something intelligent. The decision was made. The data would be shared with the international scientific community under strict confidentiality. Independent verification would be conducted by observatories around the world. The Hubble Space Telescope would be redirected. Ground-based telescopes in Chile, Hawaii, and South Africa would confirm the findings. And if the data held up, if every independent analysis came to the same conclusion, then humanity would be told the truth. The 30-day countdown had begun. To understand what James Webb found, we need to understand how it sees, how it's possible to detect the chemistry of a planet's atmosphere from 124 light-years away, how we can be 99.7% certain that what we're seeing is life. The answer lies in light itself. Light is not just illumination. Light is information. Every photon that reaches us from across the cosmos carries a story encoded in its wavelength, a history written in the spectrum. When starlight passes through a planet's atmosphere during a transit, the molecules in that atmosphere absorb specific wavelengths. Oxygen absorbs at 760 nanometers. Water vapor has a distinctive signature at 1.4 microns. Methane shows up at 3.3 microns. Each molecule leaves its fingerprint on the light, and James Webb can read those fingerprints with extraordinary precision.
But here's what makes this telescope revolutionary. It doesn't see invisible light like our eyes do. It sees an infrared, the heat signature of the universe, the wavelengths where molecules really talk, where their chemical bonds vibrate, where their presence becomes unmistakable. Previous telescopes could detect hints of atmospheres, suggestions of composition, but James Webb sees in exquisite detail. It can distinguish between different isotopes of the same element. It can detect molecules present in parts per million. It can see what Hubble could only guess at. And what it saw on Eden 9b was an atmospheric composition that defied non-biological explanation. Let's talk about oxygen. On Earth, our atmosphere is 21% oxygen. That seems normal to us, natural, but oxygen is actually a highly reactive gas. It shouldn't exist in our atmosphere at all. It should have bonded with rocks billions of years ago and disappeared. The only reason we have oxygen is because life produces it. Plants, algae, cyanobacteria, photosynthesis, living organisms constantly pumping oxygen into the atmosphere, replacing what's lost to chemical reactions. Without life, Earth's oxygen would vanish in a few million years, a geologic blink of an eye. So when James Webb detected 21% oxygen on Eden 9b, that was the first red flag. Or rather, the first green flag, the first sign that something biological might be happening. But oxygen alone isn't proof. There are some rare geological processes that can produce oxygen. Photodissociation of water vapor in the upper atmosphere. Unlikely, but possible. Then came the methane. Methane on Earth comes from two sources: geological processes, like volcanic activity, and biological processes, like decomposition and microbial metabolism. The vast majority of Earth's atmospheric methane comes from life: bacteria in wetlands, microbes in the guts of animals, decomposing organic matter. And here's the key: methane and oxygen destroy each other. They react chemically. They can't coexist in an atmosphere for long, not unless something is constantly producing both of them. On Eden 9b, both gases were abundant, both were stable, both were being continuously replenished. That's not geology, that's biology. But the smoking gun was dimethyl sulfide, DMS, a molecule with a very specific and very limited origin. On Earth, DMS is produced almost exclusively by marine phytoplankton, tiny organisms in the ocean that photosynthesize and metabolize sulfur compounds. When they die and decompose, they release DMS into the atmosphere.
There is no volcanic process that creates DMS, no chemical weathering, no photochemical reaction. If you detect significant amounts of DMS in a planetary atmosphere, you are detecting life. Period. And Eden 9b's atmosphere was rich with it. The concentration was approximately 40 parts per billion, higher than Earth's natural levels, suggesting vast oceans teeming with photosynthetic organisms, a global biosphere, life on a planetary scale. But the scientific community doesn't accept claims based on intuition or single observations. They demand statistical proof, mathematical certainty, and that's where the 99.7% comes from. The calculation was performed using Bayesian probability analysis, a mathematical framework for updating beliefs based on evidence. You start with a prior probability, how likely you think something is before seeing any data. Then you incorporate new evidence and calculate a posterior probability, how likely it is given what you've observed. For Eden 9b, the analysis considered every possible explanation for the atmospheric composition. Probability of volcanic activity producing these signatures? Less than 0.1%. Probability of photochemical reactions creating this combination? Less than 0.05%. Probability of instrument error or data contamination? Less than 0.01%. probability of unknown geological processes, conservatively estimated at 0.14%. Add all the non-biological explanations together, and you get a combined probability of approximately 0.3%, which means the probability of biological activity is 99.7%. In scientific terms, this is what we call 5 sigma confidence, the gold standard, the level of certainty required to claim a discovery in physics, the same standard used to confirm the Higgs boson, the same standard used to detect gravitational waves. We are not talking about a hunch. We are not talking about a maybe. We are talking about mathematical near certainty. But numbers on a page, however convincing, don't capture the emotional weight of what this means, the philosophical earthquake this discovery represents. For centuries, we've wondered if life was common or rare in the universe, if Earth was special or ordinary, if we were alone or surrounded by biology. Eden 9b answers that question. Life is not rare. Life is not a fluke. Life, it seems, is what the universe does when given half a chance. 124 light years. That's close. Cosmically speaking, that's next door. That's our neighborhood. If there's life that close, if it appeared independently on another world that's similar to ours, then the galaxy must be teeming with it. Billions of planets, trillions of ecosystems, an incomprehensible abundance of biology spreading across the stars. We are not alone. We have never been alone. We've been living in a living universe all along, and we just didn't know it. But that realization brings with it new questions, darker questions. If life is common, what else is out there?
There's a difference between 95% and 99.7%. It seems like a small gap, a few percentage points. But in science, that difference is everything. 95% is the standard threshold for statistical significance. It's the line where scientists say, yes, we're confident this is real. It's enough to publish a paper, enough to claim a discovery. But there's still room for doubt, still a 5% chance of being wrong, still the possibility of a fluke, a false positive, an error in the data. 99.7% is different. 99.7% is the level of certainty where doubt becomes unreasonable, where skepticism becomes denial, where the evidence is so overwhelming that refusing to accept it requires inventing ever more implausible alternative explanations. To put it in perspective, we are more certain that life exists on Eden 9b than we are of most things we consider absolute facts. We are more certain than most murder convictions that send people to prison for life. We are more certain than the medical trials that approve life-saving drugs. We are more certain than the engineering calculations that put humans on the moon. 99.7% certainty means that if you were to run this analysis 1,000 times with 1,000 different exoplanets, you would be wrong 3 times. 3 false positives out of 1,000. Eden 9b is not one of those 3. But here's what makes this percentage truly terrifying. It's not the upper limit. It's the lower bound, the most conservative estimate possible. The 99.7% calculation assumes several worst-case scenarios. It assumes our understanding of atmospheric chemistry might be incomplete, that there could be unknown geological processes we haven't discovered yet. It assumes the instruments on James Webb could have unknown systematic errors we haven't accounted for. It assumes the statistical models might have hidden biases we haven't detected. Even with all those pessimistic assumptions, even bending over backwards to be skeptical, even trying to find ways to be wrong, the math still says 99.7%. If you remove those conservative assumptions, if you take the data at face value without artificially inflating uncertainty, the probability jumps to 99.97%, 3 nines.
we'd be more certain that life exists on Eden 9b than we are that the sun will rise tomorrow. But scientists are trained to be conservative, to err on the side of doubt, to never claim absolute certainty. So they reported 99.7%, and the world was about to learn what that number meant.
Independent verification began immediately. Every major observatory on Earth and in space was tasked with confirming the James Webb findings. The Hubble Space Telescope, old but still functional, was redirected to observe Eden 9b during its next transit. Hubble doesn't have the same infrared sensitivity as Webb, but it could still detect major atmospheric features. The results came back in 72 hours. Oxygen, confirmed. Methane, confirmed. Water vapor, confirmed. The readings matched Webb's data within the margin of error. Ground-based telescopes in the Atacama Desert of Chile, home to the world's most powerful radio and optical instruments, trained their eyes on HD 8472. They couldn't see Eden 9b directly, it was too small, too distant. But they could measure the star's light during transits. They could see the dips in brightness, the spectral absorption lines. They saw oxygen. They saw methane. They saw the unmistakable signature of an atmosphere in chemical disequilibrium, an atmosphere that should not exist without life. The European Southern Observatory's Very Large Telescope in Chile, confirmed. The Keck Observatory in Hawaii, confirmed. The South African Large Telescope, confirmed. One by one, every independent team came to the same conclusion. The data was real. The biosignatures were genuine. The probability held firm, 99.7%. But verification wasn't just about checking the numbers. It was about understanding what those numbers meant, about modeling what kind of biosphere could produce such strong signatures. Computer simulations were run, planetary models incorporating atmospheric chemistry, ocean dynamics, stellar radiation, and biological metabolism. The simulations painted a picture of Eden 9b that was both familiar and alien. A planet slightly larger than Earth, with deeper oceans covering approximately 80% of its surface. Ocean depths averaging 4 kilometers, twice as deep as Earth's mean ocean depth. Vast marine ecosystems stretching across hemispheres. The oxygen and DMS signatures suggested enormous populations of photosynthetic organisms, not just in the oceans, but possibly on land as well. The models predicted substantial land masses, perhaps 30 to 40% of what Earth has, and if there was land above water, there might be something living on it. But here's where the simulations started returning unsettling results. The atmospheric composition wasn't just consistent with simple microbial life. The ratios of gases, the stability of the system, the complexity of the chemical cycles, they suggested something more, something the scientists started calling a mature biosphere. On Earth, it took 3.5 billion years for life to evolve from simple microbes to complex multicellular organisms, another 500 million years to develop land plants, insects, animals. Evolution is slow, patient. It takes geological timescales to create complexity. But Eden 9b's star is older than our Sun, 6.2 billion years old compared to our Sun's 4.6 billion. If Eden 9b has been in the habitable zone for most of that time, if life arose there as early as it did on Earth, then that biosphere has had nearly 2 billion additional years to evolve. 2 billion years is a long time. On Earth, 2 billion years ago, life was entirely microbial, single-celled organisms in the oceans, nothing on land, nothing complex. But give evolution another 2 billion years, and you get forests, you get animals, you get ecosystems of staggering complexity. You get us.
The implications were inescapable. If Eden 9b's biosphere was 2 billion years more mature than Earth's, it might not just harbor microbes and algae.
It might have its own version of fish, of forests, of animals that swim, crawl, fly. And if it had all of that, statistically, evolutionarily, it might have something else, something that looks up at its own night sky and wonders if it's alone. The scientists didn't want to speculate, didn't want to make claims beyond what the data could support. The biosignatures proved life existed. They didn't prove intelligence, but they couldn't ignore the possibility. The probability calculations were run again, this time factoring in the age of the system, the strength of the biosignatures, the stability of the atmosphere. What are the odds that a biosphere this mature, this robust, this chemically complex has evolved intelligent life? The models were cautious, conservative. They made no assumptions about the frequency of intelligence in the universe. They only calculated based on what we know about Earth's evolutionary timeline. The result? A 14% probability that Eden 9b harbors not just life, but intelligent life. 14% doesn't sound like much, but 14% means roughly 1 in 7 odds. Those are not comforting numbers when you're talking about alien intelligence 124 light-years away. 1 in 7. Would you get on an airplane if there was a 1 in 7 chance something intelligent and unknown was waiting at your destination? But here's the truly terrifying part. 14% is the probability of intelligence existing now, right at this moment. The probability that something is alive and thinking on Eden 9b today. But light takes time to travel. The photons James Webb detected left Eden 9b 124 years ago, in the year 1900, measured by Earth's calendar. We're not seeing Eden 9b as it is now. We're seeing it as it was in 1900. On Earth, 1900 was the dawn of the modern age. The Wright brothers hadn't flown yet. Radio was brand new. Einstein hadn't published relativity. The internal combustion engine was just becoming practical. We were on the edge of the technological revolution. 20 years from powered flight, 45 years from splitting the atom, 70 years from going to space. If intelligent life existed on Eden 9b in 1900, where might they be now? What might they have built in the last 124 years? We went from horse-drawn carriages to landing on the moon in 69 years, from the first computer to artificial intelligence in 75 years, from no flight to interplanetary spacecraft in 60. What could an intelligent species accomplish in 124 years? The thought hangs in the air like smoke, heavy, ominous, unavoidable. We were looking at Eden 9b in the past, but Eden 9b, right now, at this very moment, might be looking at us in our past, seeing our atmosphere as it was in 1900, detecting our biosignatures, running their own probability calculations, coming to the same conclusion we did. They are not alone either. And if they had the same 124 years of technological development we've had, if they followed a similar trajectory, then they might already have the capability to do something about it. The 30-day deadline was approaching. The verification was complete. The data was undeniable. The world was about to learn the truth.
But now the scientists faced a new question, a more disturbing question. Should we announce this discovery? Should we tell humanity that we found life on another planet with 99.7% certainty? Or should we stay quiet and hope that whatever is on Eden 9b hasn't found us first? The news broke on October 15th, 2024, at precisely 1100 hours Eastern Standard Time. Not through NASA's carefully prepared press release, not through peer-reviewed journals or scientific conferences, but through a leak, an anonymous post
on a science forum. A grainy photograph of a classified document. The words Eden 9b and 99.7% biosignature confirmation visible in the image. Within minutes, the post went viral. Within an hour, it was on every major news platform. Within 3 hours, the stock markets around the world had frozen, triggering automatic circuit breakers as trading volumes spiked beyond normal parameters. The cat was out of the bag, and NASA had no choice but to respond. The press conference was hastily arranged. The NASA administrators stood at the podium, flanked by the world's leading astrobiologists and exoplanet specialists. The room was packed with journalists. Camera flashes strobed like lightning. The entire world was watching. The administrator's hands shook slightly as he adjusted the microphone. This was the moment he'd rehearsed 100 times in his mind. The moment every space agency director had prepared for since the dawn of the space age. But no amount of preparation could adequately capture the weight of what he was about to say. Ladies and gentlemen, I can confirm that on September 14, 2024, the James Webb Space Telescope detected compelling evidence of biological activity on an exoplanet designated Eden 9b, located 124 light-years from Earth. The atmospheric composition of this planet exhibits multiple biosignatures that have been independently verified by observatories worldwide. The statistical analysis indicates a 99.7% probability that these signatures are of biological origin. Silence. 3 seconds of absolute silence. The journalists processing what they just heard, the confirmation that the leak was real, the acknowledgement that changed everything. Then chaos. Hundreds of voices shouting questions simultaneously, cameras clicking frantically. The administrator raised his hand for quiet, but the questions kept.
Does this mean aliens exist? Is the life intelligent? Are we in danger? Has there been any communication? What does this mean for religion? When will we send a mission? The administrator waited for the noise to subside, then continued. To be clear, the biosignatures we've detected are consistent with microbial life or simple photosynthetic organisms. We have no evidence of intelligence, no signals, no artificial structures. This is a biological discovery, not a first contact scenario. But his carefully worded clarification did little to calm a storm. The world had heard the number, 99.7%. The world understood what that meant. We are not alone. The reaction was immediate and global. In New York, Times Square filled with crowds staring up at the news tickers. Life found on distant planet, scrolling across the screens in every language. Some people cheered, others wept. Many simply stood in stunned silence, trying to comprehend the magnitude of the announcement. In Tokyo, the Prime Minister called an emergency cabinet meeting. Japan's space agency JAXA was already planning next-generation telescopes that could study Eden 9b in even greater detail. In Beijing, the Chinese government released a statement congratulating the international scientific community and pledging cooperation in further study of the discovery. Behind closed doors, their space program accelerated plans for deep space observation satellites. In Russia, the Russian Orthodox Church issued a statement affirming that the discovery of life elsewhere in the universe was not incompatible with Christian theology. God's creation, they said, was vaster than human imagination had previously allowed. The Vatican made a similar announcement. The Pope himself appeared on the balcony of St. Peter's Basilica and addressed the crowd below. God's garden is larger than we knew, he said. We welcome our distant cousins with wonder and humility. But not all religious reactions were so measured. In some communities, the news triggered existential crisis. If life existed elsewhere, what did that mean for humanity's special place in creation? Were we no longer unique? No longer chosen? Theological debates erupted. scholars scrambled to reconcile ancient doctrines with modern cosmology. Some saw the discovery as validation that the universe was designed for life. Others saw it as evidence that human exceptionalism was an illusion. And some saw it as a warning, a sign of the end times, prophecy fulfilled. The internet exploded with theories, speculation, and conspiracy. Entire subreddits dedicated to Eden 9b appeared within hours. Amateur astronomers tried to image the planet with backyard telescopes, even though it was far too small and distant to see. Science communicators worked overtime to explain spectroscopy and biosignatures to a public hungry for understanding. But beneath the excitement, beneath the wonder and celebration, there was something else, something darker.
Polling conducted in the days following the announcement revealed a surprising statistic. 43% of people surveyed said they felt anxious or afraid about the discovery. Not excited, not curious, afraid. Because the number wasn't just 99.7% probability of life, that was the number everyone focused on. But there was another number buried in the technical reports that most people missed. 14%. The probability that the life on Eden 9b might be intelligent. 1 in 7 odds. Russian roulette has 1 in 6 odds. This was worse. And that's when the questions started getting darker. If there's intelligent life on Eden 9b, and they're technologically advanced, could they detect us the same way we detected them? The answer was yes. If they had telescopes comparable to James Webb, if they'd been watching our solar system, they would see the same biosignatures in Earth's atmosphere that we saw in theirs. They would know we're here. Could they reach us? 124 light years. That's far, impossibly far by current human technology. Our fastest spacecraft would take over 2 million years to get there, but we've only had spaceflight for 70 years. What if they've had it for 1,000, 10,000? What if they've had longer? And here's the question that kept scientists awake at night, the one they didn't want to say out loud in press conferences. If they detected us, and if they have the technology to cross interstellar space, would they come? And if they came, would they come in peace? Human history doesn't offer comforting precedents for first contact between civilizations. When Europeans discovered the Americas, it didn't end well for the indigenous populations. When technologically advanced cultures encounter less advanced ones, the outcome is rarely benevolent. We want to believe that an intelligent species capable of interstellar travel would also be wise, peaceful, enlightened. That the same technology that allows them to cross the stars would come with a moral evolution that transcended conquest and violence. But that's hope, not data. We have no evidence that intelligence correlates with benevolence. We have plenty of evidence on Earth that it doesn't. The thought began to spread. Started as whispers in online forums, then articles in fringe publications, then eventually mainstream media had to address it. What if the discovery of Eden 9b wasn't a miracle? What if it was a mistake? What if we should have stayed quiet? There's a concept in astrobiology called the Great Filter. It's an attempt to solve the Fermi paradox, the puzzling question of why, if the universe is so vast and so old, we haven't detected any signs of intelligent alien civilizations. The Great Filter hypothesis suggests there's some barrier, some challenge in the evolutionary path from simple chemistry to spacefaring civilization, a filter that most life doesn't pass through. The question is, where is the filter? Is it behind us? Was the hard part going from non-life to life? From single cells to complex organisms? From intelligence to technology? Did we already pass through the filter, meaning intelligent life is incredibly rare and we might be alone in the galaxy? Or is the filter ahead of us? Is there some inevitable catastrophe that befalls every technological civilization? Nuclear war, environmental collapse, artificial intelligence gone wrong? Do all species destroy themselves before they can reach the stars? The discovery of Eden 9b suggests the filter isn't at the origin of life. Life, it seems, arises relatively easily. The universe is abundant with biology. The filter must be somewhere else. And that's what made people afraid. Because if the filter is ahead of us, if there's some great silence waiting for every species that reaches our level of technology, then Eden 9b might not just harbor life, it might harbor a warning. But there was another implication, one that scientists discussed in hushed tones in university hallways and secure conference rooms. An idea that sounded like science fiction but was rooted in perfectly sound reasoning. If life is common in the universe, if planets like Eden 9b exist within...
For centuries, we searched for life in the stars, never imagining that when we finally found it, the discovery would make us question everything we are. That faint signal, that pattern in the light, is more than science. It's a message written across the universe itself. Life does not belong to us. It never did. Somewhere out there, under an alien sky, something is breathing, something ancient, something aware. We call it discovery, but maybe from their side of the sky, they call it contact.